This week we'll be taking a look at a very important and useful part of programming, the concept of functions. Functions provide programmers with quick and easy ways to accomplish specific tasks. Functions are a lot like modules with one exception, which I'll discuss below. There are two types of functions. Ones programmers create themselves, and library or built-in functions, which are a part of the programming language. We'll explore both types in this presentation. So without further ado, let's take a look at Chapter 6, Functions. Chapter 6 is broken down into three sections. Section 1. Section 1 offers a general introduction to functions and takes a look into library functions that generate random numbers. Section 2 will take a look at how and why you might want to create your own functions. And in Section 3, we'll explore some more popular library functions. This will be far from an extensive list, but should still give you a good idea of some of the common functions available and how they can benefit you as a programmer. I've used the word function quite a bit already, so maybe it'd be a good idea to take a look at exactly what a function is. As the slide suggests, a function is a module that returns a value back to the part of the program that called it. You may recall when we discussed modules in Chapter 3 that modules allow you to chunk down your programs into smaller sections of code, with each section focusing on a specific task or related tasks. You may, for instance, have a module that displays a welcome message, a module that calculates sales tax, a module that calculates the total cost of a purchase, and finally maybe a module that displays the result. Each module is devoted to a specific task, and all the modules combined together make up the program. You learn that modules allow you to create reusable code that will save you time when creating programs. And modules also make it easier to work in a team environment where each member of the team can focus on their own specific modules and not have to be concerned about the work that the other people on the team are doing. Everyone's working on a specific task, and ultimately those tasks will be combined together to form the completed program. Modules are great, but one of their limitations is that the output generated by the module is not easily returned back to the main part of the program. So anything generated within the module typically has to be displayed or used within the module and is not returned to the main part of the program. Functions offer the same benefits as modules, but without the limitation. Functions can return values back to the statement that called it using the return statement. This will all make more sense when we work with a couple examples further along. As mentioned previously, you can write your own functions, or you can use pre-written library functions that come with all modern programming languages. These library functions are provided by the language's creators to help ease the amount of work you have to perform when writing programs. Library functions typically cover common tasks that you are likely to perform on a regular basis. By using your programming language's library functions to handle common tasks for you, you do not have to create the code yourself. An enormous time saver. These library functions are many times referred to as black box functions because you invoke the function performs the task it's designed to perform, and then it returns your result to use in the rest of your program. All of this is done without you seeing or needing to see the actual code behind the scenes. You called the function, it did its thing, you got the result you wanted, no muss, no fuss, didn't need to know what was going on, it just went into a black box, did its thing, gave you the result you want. One of the more common library functions provided by most languages is the ability to generate a random number. Random numbers are useful in many types of programs that you may find yourself creating. Random numbers are useful in game programming, like determining which number to display in a simulated rolling of a pair of dice, or which card to show in a simulated card game. They are useful in simulation games to help determine what is going to happen to a character in a game, for instance. If a random number below 5 is generated, the player may be showered in riches, but if it's a 5 or larger, the player may lose life points, and so forth. Statistical programs use random numbers to help prevent testing bias. If a statistician were to pick and choose specific pieces of data to work with, the results could be skewed. By using random numbers, you're better ensured a good representative sampling of data and more accurate results. Computer security and encryption take advantage of random numbers by helping prevent the selection of recognizable patterns. If a hacker can identify a pattern, they can exploit it. Randomness makes this a little bit harder. So how do you use a random number generator library function? Ultimately, that will depend on the programming language you're coding in, but in pseudocode, you typically start with a set statement. Since a function returns a value, you need to set up a place to store the returned value. So set variable name, in this case the variable's name is number, equal to, follow that by the name of the function, in this case random, and opening parenthesis, any arguments that you need to pass in this case we're passing in 1 and 100, which represent the range you want your random number selected from, and then finally a closing parenthesis. When the program runs and this line of code is reached, the parser searches out for the function with the name random. The arguments 1 and 100 are passed in, and the function does its black box work and returns a random number between 1 and 100. When the value is returned, it is stored in the number variable. Once you have that returned to the calling statements, you are able to use that variable wherever else you want to use it in your program. The following slide will show you various versions of the random function as they're written in different programming languages. For instance, in JavaScript, you would write math.random and then have an opening and closing parentheses. In C#, new random, opening and closing parentheses. In Python, it's random.randint, open parenthesis, and then your two numbers, the range that you want to select from, separated by a comma. In PHP, it's rand, opening and closing parenthesis, with two arguments, also separated by a comma. And in Ruby, it's also rand, but instead of separating the arguments with a comma, they're separated by two dots. So you can see the syntax of the function is different in each language, but each language recognized the value of being able to generate random numbers in programs, so they each provided a library function to accomplish the task. Library functions are great, and they can greatly reduce the amount of time it takes to create a program, but library functions are just part of the function story. You can also create your own user-defined functions. When you have a task that needs to be repeated throughout your program or in other programs, it's beneficial to go ahead and create a function around that task so you can just reuse the code over and over again as often as you need it. When writing your own functions using pseudocode, you first start with the function header. The header starts with the word function, followed by the data type that will be returned by the function, then the function name, an opening parenthesis, the data type of the parameter if there is one, and finally the name or names of the parameters that will hold data being passed into the function. In our example here, the function's name is funcName. It's of the integer data type. It has one parameter. It's an integer, and the parameter's name is num1. After the function header is the function body. The body consists of the lines of code that will perform the task you're creating the function to perform. So the body would be where you would calculate sales tax or obtain somebody's input information. Whatever it is that the function is designed to do, that code would be contained within the function body. The final part of the function body is the return statement. The return statement is the word return followed by the value that you're returning to the statement that called the function. That'll make more sense once we walk through an example. So let's take a look at a sample program using a user-defined function. Let's do a line-by-line walkthrough of an example program that contains a function that adds the ages of two friends. Line 1 is simply a declaration of the main module. Line 2 is just a comment. Comments are important, but not a whole lot to them to discuss. Line 3 starts getting interesting. This is where we declare three integer variables. The first age variable will hold the value that is entered for the first age that is entered by the user of the program. The second age variable will hold the value for the second age that is entered by the user of the program. And finally, the total variable will hold the value that is returned from the sum function, which is the function we'll be working with in this case. Lines 5 and 6, as you can see, are comments. Line 7 displays a message on the screen asking the user to enter their age. Line 8 will take the value entered by the user of the program and will store it in the variable first age. Lines 9 and 10 perform similar tasks to lines 7 and 8. They're asking for the second person's age to be entered, and once entered, the value stored in the second age variable. Line 12 is a comment. Line 13 is the function call. This is the statement that will call the function named sum. Since the sum function needs to know the values stored in the first age and second age variables in order to complete its task, those values are passed in as arguments. At this point in the program, the sequential flow of the program is halted and the program seeks out the sum function. The sum function header starts on line 21. The entire function goes from lines 21 through 25. The function header starts with the word function to indicate you're creating a function, followed by integer. This is the data type that will be returned by the function. Next is the word sum. This is the name of the function. Following the name of the function are an opening and closing parenthesis with two parameters inside. The first parameter, num1, is of the integer data type, and it will hold the value passed into it by the argument first age. The second parameter, num2, is also of the integer data type, and it will hold the value passed into it by the second age argument. Line 22 declares a variable named result. This variable will be used to store the result of adding the two ages together. Line 23 uses the set statement to assign the result variable the solution of adding num1 to num2. Line 24 is the return statement that returns the value that is stored in the result variable to the calling statement. In this case, that calling statement is line 13, where we say set total equals sum, first age, second age. That is the function call that the return value will go to. Once the result is returned to line 13, the total variable is set to the value that was returned. The program then continues from line 15, which contains a comment. Line 16 handles the program's output and displays. Together you are, and then whatever the value stored in the variable total is, years old. And finally, line 17 ends the main module and the program. Some additional things to consider about functions. You can pass in as many arguments as the function needs, from 0 arguments to dozens if necessary, but the function can only ever return one value. Functions, like modules, make for faster development times and make teamwork on larger programs more manageable. You can plan your functions using something referred to as an IPO chart. Here's an example of what an IPO chart looks like. As you can see, IPO stands for input, processing, and output. To create an IPO chart, you create 3 rows. In the top row, you identify the name of the function. You break the second row down into the titles input, processing, and output. And finally, in the third row, under each title, you identify the data that needs to be input into the function. This will be your parameters. What will be done with the input? This will be your processing. And finally, at the end of the function's run, what will be returned to the statement calling the function. Here's another example of a user-defined function. This program will take the price of an item, pass it into an add tax function, and will return the total price consisting of the original price plus the applicable sales tax. So let's take a look at these line by line. In the first couple of lines here, we declare a couple of variables. The first is the variable named price, and the second is final price. Price will hold the price that's entered by the user of the program, and final price will be the output from the program that will display what the price will be once the tax is added. We next display a message on the screen asking the person how much the item cost. And whatever they enter, we're going to store in the price variable that we created above. Next, we're going to go ahead and call the add tax function. In this case, we say set final price equal to whatever's returned from the add tax function. With the add tax function, we're going to pass in the price variable, since that's where the price is stored that the function will need to work with in order to determine the tax. At this point, again, the sequential flow of the program stops and the add tax function is sought out. So we'll skip this line for right now and we'll find the add tax function. Here we go. So from the set final price line, it goes to the function real add tax real initial price line. And this is the function header. Again, we're declaring that as the function. The data type return will be real. The name of the function is called add tax, and it's going to receive, it has one parameter called initial price, and that's going to be of the real data type. The body of the function starts out by declaring a variable called tax added price. This will be the variable that will store the calculation when we multiply the price times the tax, and whatever that ends up being will be stored in the tax added price variable. And I should have started this line with the word set, so I should have said set tax added price equal to initial price plus initial price times 0.07, assuming 0.07 is the tax rate on this particular product. Once tax added price has been calculated, we can return tax added price to the main body of the program. In this case, the result of the tax added price calculation will get stored in the final price variable up in the body of the program. Once the function ends, the program returns to the set final price equals add tax price line, and again assigns the return value to the final price variable. And the last line will be to display the final price is, and then finally whatever value is stored in the final price variable. So this is just a simple walkthrough of how you can use a function to calculate a result and then pass that result back to the body of the program. There are tons of library or black box functions offered by each programming language. Each language may have some functions other languages don't have, and each language will use different syntax for the functions that they do have in common. But with those differences noted, there's still certain categories of functions that almost all languages will have. One of those is mathematical functions. Almost every programming language will have some mathematical library functions. The mathematical functions are things like square root x, or in this case the example is square root 16. What this will do is when the program is running, it will reach this line. It will run the square root function. It will pass in the argument 16, and the square root function will do its black box magic and will return a value and store it in the result variable. Returns the square root of 16 in this case. Another mathematical function would be power of, or in this case just power. So we would set the variable named area equal to whatever is returned from the library function power. In this case, this function will take the first argument and raise it by the power of the second argument. So in this case, 4 would be raised to the power of 2. Again, it's a library function that just makes it easier to calculate numbers being raised to certain powers. Some other common mathematical functions include absolute value, cosine, round for rounding, sine, and tangent. And there's tons of others. These are just some simple examples. Another common type of function is one that converts one data type to another. What happens if you have a string and you need an integer? Or what happens if you have an integer and you need a real? How do you go about converting one to another? Well, most languages will have something similar to toInteger or toReal or toString that you can use to convert one data type to another. Just a few comments on converting data types. Real numbers can store integers, so if you declared something as a real, you can store an integer in it. But integers cannot store real numbers, because real numbers need to be able to accommodate decimal places, and integers are not designed to be able to do that. And finally, if you do attempt to use the wrong data type, then the likely error you'll see is a type mismatch error. That's what will occur if you are trying to use a value as, let's say, a real when it should have been an integer, or a string when it should have been a real, something along those lines. Some other functions that you're likely to run into are formatting functions. Formatting functions allow you to format a number in a certain way. One of the common types of formatting functions is the currency format. Everyone likes to see dollars and other currencies represented with commas and decimal places and currency signs, rather than just numbers sitting on a page. So you can use something along the lines of a currency format library function. In a little example here, we declare a variable called amount, and we assign it the value of 6,450.879. And then finally we say display currency format, and we pass in the variable amount. And the outcome from this is a display that would show you a dollar sign, a comma, where the thousands place should be, and the decimal places have been rounded off. Still, other functions, very common among programming languages, are string functions. Strings are strings of text, and used very widely in just about every program. So manipulating strings with library functions is an important skill to know. One of the string library functions you should be familiar with is length. Length comes in handy in many programs where you need to know just exactly how long a word or a sentence or an array might be. Another string function you may run into is an append function, which allows you to join two strings together. ToUpper and ToLower allows you to convert a string into either all uppercase or all lowercase. The substring function can extract a character or a portion of a string out of a string. So if you have a sentence or a whole page of data and you're wondering if a certain keyword or certain sentence exists within the larger string, you can use substring to search out the keyword or phrase that you're looking for. And some additional string functions. By no means is this exhaustive. This is just a representative sampling. Each language is going to have a ton of different functions that you can take advantage of. A couple others you might run into: contains, if you're wondering if one string contains a value contained in another string. String to integer, string to real. Again, this is getting into your conversions. You're converting a string to a number, in this case either an integer or a real. IsInteger and IsReal are also two popular library functions that let you test to see whether you do need to convert the value or not. You can test to see whether the data is already of the data type that you want. If it's not, then you invoke something like string to integer or string to real, whatever it is you're trying to accomplish. So, with all that down, you should now be quite familiar with a number of concepts. You should understand what library and black box functions are. You should understand how to write your own functions with a function header and a function body and the return statement. You should understand how to call functions, how to use arguments when calling a function, how to use function parameters, and how to return data from a function. If you didn't pick up on all these, you might want to review the video and check your book as well for more information. So what's next? If you haven't already, read the chapter, review the PowerPoint slides, which is essentially just what we went through, but if you want to go through the slides one at a time without my narration, then they're in the Angel folder. And of course, study for and take the quiz, and work on and complete this week's project. After that, next week will be summer break, and you'll have a week off. When we come back from summer break, we'll be working on Chapter 8, which deals with arrays. It wouldn't hurt to get a head start reading about arrays. It's an important programming topic, and the more you can understand going into the discussion, the better you'll understand the discussion. Well, I hope this has been helpful to you. If you have any questions, please get a hold of me. Reaching me via email is typically the best way to go. And I wish you the best of luck.